Hi, today I'll be unboxing and testing the Hardell Mini Cordless Rotary Tool. Hardell offers a variety of toolkits and I bought this one in Japan, which is why the packaging includes Japanese text. If this exact model isn't available in your country, Hardell offers similar options worldwide. This model features a 600 mAh lithium-ion battery, a 3-speed motor, and comes with 42 accessories. This tool is for sanding, engraving, milling, polishing, cleaning, and for drilling small holes. I'll demonstrate its capabilities by shaping an HDPE sheet to create a robot chassis part. The tool runs on 3.7 volts with speeds of 5,000 RPM, 10,000 RPM, and 15,000 RPM. It features two collet sizes, 1.6 millimeters and 2.3 millimeters. Let's open it up. Slice it open. Inside we have this neat little black case. Let's open the case and see what we have. I'll just remove this little bag. Here's the Hardell Mini Cordless Rotary Tool. It's quite compact and light. The metal button locks the output shaft for tool changes, and the black button at the back powers it on. At the rear, there's a USB-C charging port. This section shows the current speed settings. Here's the USB-C cable for charging. Insert the male connector into the tool and the USB-A connector into a power adapter, power bank, or PC to charge. There's also an instruction manual localized in Japanese for the Japanese market, but I'm sure it's usually in English or perhaps in the regional language, as in my case. Here we have a little packet of sanding drums. Here's a close-up of one of them. These sanding drums are cylindrical abrasive sleeves that fit over a rubber drum mandrel, which should be inside this plastic case that encases all the little tools. I'm quite impressed with the handy storage case. It'll definitely keep everything organized. Let's open this little case with all the little tools. Here's the rubber drum mandrel I was just talking about. So the abrasive sleeve fits on just like that. Here it is close up. There only looks to be about a dozen or so tools in there, including the collets. So let's see what we have. Here are all the accessories. These are the engraving tools, a couple of polishing tools, a mini cup bristle brush, some collets, 2 drill bits. These are grinding stones. Here we have a bristle brush wheel, and here are a dozen or more hollow cylindrical abrasive sleeves that make up the remaining number of the accessories. Let's unscrew the collet nut. Inside you can see the collet fitted in place. Let's pull the collet out. Here I have a collet nut holding a 2.3 millimeter diameter collet, and for example I'm going to insert this cylindrical grinding stone tool with a 2.3 millimeter diameter shank. Remember, we need to hold down this lock button to stop the output shaft from rotating. With the shank of the grinding stone inserted, screw on the collet nut and tighten it. There we have it, ready to go. Let's turn this on. That's pretty slow. No wonder I haven't charged it up yet. So I'll cut the camera and charge the rotary tool. Here I'm outside to cut the robot chassis part from an HDPE kitchen cutting board. I'm using a hot knife for the initial cut. Be sure to wear a mask to avoid inhaling fumes, and also make sure you do this outside. I made a separate video about this hot knife. Check the description for the link or click on the link at the end of this video. With a little help from a cold cutter knife, I cut free the robot chassis part. That's a good start, but I'll need to prepare the workpiece a little bit more by further trimming with the cold cutter knife. Here I am using the cold cutter knife to edge toward the drawn out lines of the robot chassis shape so that we don't give the rotary tool too much work to do. I need to machine the entire end surface here, so let's apply a marker pen on it. I first tried out a sanding drum. I wasn't sure how much plastic would be removed, so I didn't apply too much pressure initially, but I soon realized that I was struggling to achieve a flat finish. I tried clamping the workpiece at 90 degrees and did some more sanding using the sanding drum. The marker pen that was applied acts as a guide, though it does not guarantee a flat finish, but it certainly helped. As you can see, I applied more pressure and the Hardell rotary tool is handling it quite well. Here's the edge close up. Looks fairly straight, but let's check that edge with a small machinist square. Well, first of all, the edge looks square relative to the main surface, but as this footage shows, the edge is not exactly flat or straight. It seems like I should switch to a different tool, but this sanding drum is doing a great job at removing material, so while it's still attached to the rotary tool, I'll use it to clean up a few more edges before swapping it out. As we can see, the sanding drum can efficiently remove HDPE material. I repeated the same process on the various other edges of the workpiece. However, I can't use the sanding drum on the internal 90-degree corners. It's important to check that your edges are square, so I use the machinist square again. I've started to use this cylindrical grinding stone. If we use the cylindrical stone in the same manner as we did with the sanding drum, we still can't get into the internal corners. So I decided to try this reverse taper grinding stone. You can see that it has clogged up a bit, but that can be easily tidied up by using the bristle brush wheel. One advantage of this type of grinding stone tool is that it has a nice wide and flat end, which is useful for machining flat surfaces. With this tool you can get right into the corner no problem. The end face of the reverse taper grinding stone can also act as an end mill. Using this grinding stone tool as an end mill, we can achieve a flat edge without too much effort. I think you can see that the reverse taper grinding stone has done a good job at machining a flat edge surface that is also square relative to the main surface. I was able to machine all the remaining edges accurately using this grinding stone tool. I also found the cylindrical grinding stone valuable. I'll just try the bristle brush wheel to help tidy up the edges a bit. Actually, as I suspected, it didn't really help that much. A cold cutter knife works well to initially remove the large amount of swarf and to tidy up the rough edges. Next, I use this bullet-shaped polishing bit to polish and smoothen the edges more. It is actually surprisingly hard to attain a smooth finish with HDPE, but I am happy with how this polishing bit performed. The robot chassis part is complete, and the Hardell rotary tool performed exceptionally. I was able to achieve square, flat edges according to my design within a tolerance of plus or minus 0.1 millimeters. Thank you for watching.